Hi everybody, and welcome to my talk, Intersectionality in LGBTQ plus health research, practical analysis in R using upset plots. My name is Chris Battiston, my pronouns are he, him, his, and you can always reach me at my email, chris.battiston@wchospital.ca. So a little bit about me. I work for a hospital, Women's College Hospital in Toronto, Canada, that really prides itself on improving healthcare for marginalized folks. We do a lot of work on health equity, system equity, and looking at ways to improve healthcare right across the board. With programs like the first outpatient gender confirming surgery program in Canada to revolutionizing HIV and substance use disorder care, our research reflects the broad diversity of this work. I'm the Red Cap administrator for the hospital, so although I don't have direct involvement in the studies, I support and guide how teams can build their projects in the most effective way. Why am I doing this talk? Representing marginalized populations through data equity and justice is something that I strive to bring to my work every single day. I am developing standardized, inclusive, equitable, and sensitive demographics questions that will allow more research participants to see themselves in how the questions are asked and, more importantly, how the data are analyzed. Along with better questions, we need to have better methods for this data analysis. Data visualization has been a passion of mine for many years, so looking at ways to integrate data equity and marginalized populations with data visualization was a perfect fit for me. Upset charts fill the gaps a lot of studies have in their data analysis, so I'm hoping that talks like this expose more people to their usefulness. To the point of this talk, fingers crossed, I'm going to do a demo. Okay, so you should see my RStudio screen now. Please ignore the multiple and various tabs along the top there. That's my tab Chaos in full swing. But the important piece here is the code window where we're going to talk about how I've set up the upset plots, the data set that I will be using, and then we'll look at some examples of ways that you can, or different types of upset plots that can be generated. So I'm using the mass library here because I use the survey data set. I find that to be a very good use case for testing and for playing around with proof of concepts, like figuring out what an upset plot does. Dplyr, this is for data manipulation, selecting, filter, mutating, etc. Tibbles, upset plots really like working with tidy data, so tibbles are a great way in order to do that. The complex upset plot is the package that I've chosen to use for the purposes of this talk. There are many others, including the very, very popular upset R, but I find that for the purposes of introducing this concept to new users, the complex upset package is the best one to use. Sorry, got a little tongue-tied there. One of the reasons for that is that it integrates very, very well with the ggplot2 package. Here I am subsetting the data from the survey, or pulling the data in from the survey data. And here I am subsetting just the three variables that I want to look at, in this case, sex, smoke, and exercise. I'm going to remove rows with missing values and then convert factors to character because complex upset works better with logical indicator columns. Okay. Here I am creating a function to create my make indicator columns. I'm going to put all the unique values in sorted order. I will then, for each level, create a column where true if row matches the level. And then I put it into a table with column names like sex male. I then apply the function to each variable. So in this case, sets sex, where I've applied it to the df sex with the variable name sex. And then the same for smoke, and then the same for exercise. Here I am doing the combining all the indicator columns into a single data frame, and then storing the column names for reference in the upset plots. Here is a basic example of upset plot code, looking at exactly three-way interactions. Here I am specifying the columns to use for the intersections. Here I'm going to be looking at exactly the intersections of exactly three sets. And I'm going to say minimum of one row. I want the largest intersection on top, default plot showing sizes here, and width of the set size plots relative to the intersection. And again, you can go in and you can play around with these once you've become comfortable with how the plot looks and how the plot interacts with or how the code interacts with the plot. So here's a basic example of an upset plot. I will be going through the makeup and the anatomy of an upset plot momentarily. Suffice it to say, this is a very new way for most folks to look at data, so it can be a little bit overwhelming. But again, I just wanted to show you what a basic upset plot looks like for right now. We'll dig into the components momentarily. Here's the code for a second example of an upset plot that I wanted to show. In this case, we're going to be adding labels. There's going to be some fancy stuff done. And it's obviously a little bit longer of a code chunk, so I'm going to run it right now. And it doesn't quite fit into the screen here nicely, but it would if it was if I was using full screen. So suffice it to say, we've now got a label here with a little bit of a description. Our column widths are a little bigger, and it just looks a little nicer. And then finally, this is the code chunk that I'm going to be using for the discussion of the components of an upset plot. A couple of things that I'm doing here. You can set the minimum cut, so the minimum intersection size. I'm specifying this to 2, and then that gets called here. The other thing that I'm doing is filtering out any ends of 1, because we don't want ends of 1 in the purposes of this proof of concept. So we're going to drop any columns that have just 1 response. I'm now going to run this code, and when I move this over, there's our upset plot that we will now be looking at in more detail. Okay, so here's the upset plot with the 3 different areas highlighted that I am going to discuss. The intersection size, this top bar plot up here at the top, the vertical bars at the top represent the number of survey respondents in each intersection or each specific intersection of categories. The numbers on the top of the bars indicate the exact count. So if this bar here has 50 responses, the next one has 47, and so on. The plot on the left side here is the set size. So and these show the total number of respondents in each individual category, regardless of intersections. So for example, the smoking never has the largest bar, indicating that this category contains the most respondents overall, and it looks to be at about 200 or so responses in that particular category. The next and final piece of the upset plot is this intersection matrix down at the bottom here. And this is really what makes an intersection or an upset plot an upset plot. Each column corresponds to an intersection. Black dots indicate which categories are included in that intersection, and gray dots indicate categories that are not part of the intersection. Connected black dots show the specific combination of categories for that intersection. So for example, a column with black dots at sex female, smoke never, and exercise frequently represents all female respondents who never smoke and exercise frequently. The plot allows quick identification of which combinations of demographic and lifestyle factors are most common. In this example, respondents who are female, never smoke, and exercise sometimes make up the largest group. Less frequent intersections, shorter bars, show rarer combinations, which may be important for exploring intersectionality in behavior and demographics. The upset plot clearly separates set-level information, how many people are in each category individually, from intersection-level information, how many people fall into a particular combination of categories. This is useful for identifying patterns in multidimensional, categorical data that would be difficult to visualize with a Venn diagram or other more commonplace visualizations. Some final thoughts. Clinical research is rapidly becoming more complex, and with the realization that people are not just a bunch of single, isolated variables, new data visualization and analysis tools are needed. Upset plots are a step in the right direction, but more work needs to be done to standardize their use and develop supplemental methods to support them. Methods shown today are intended for new users. The upset R package is the preferred method, but is more complex. Here are two of the critical readings that I refer to and I refer people to when I am talking about upset plots. Oops, sorry about that. The first one is Alexander Lex's paper from 2014 called Upset Visualization of Intersecting Sets. And this is the paper where he starts talking about what upset plots are and introduces them to the data visualization community. The second one is Jake Conway's paper in collaboration with Alexander Lex and Niels Gellenborg, who also was involved in the 2014 paper, where they introduced the upset R package. Both papers are highly recommended, and if you are interested in learning more about upset R or upset plots in general, please feel free to reach out to me. Again, my email address is chris.battiston@wchospital.ca. Thank you very much for attending my talk today. I look forward to answering any questions.